Assalamu alaikum, dear students. Welcome to the 13th program in Operating System Lecture Series. And today we'll discuss networks and OSI reference model. You'll recall in our previous program, we did discuss the importance of the network. Why do we really use networks? Then we looked at various types of networks. We looked at various topologies for the networks. Today we'll discuss the network types. We'll expand on our discussion of LANs, local area networks, metropolitan area networks, and wide area networks. And apart from that, we'll discuss the OSI reference model, that is Open Systems Interconnection Reference Model, which is developed and which is a standard developed by ISO, that is International Standards Organization. Our next issue, that is the network types. Primarily, there are three network types: the local area networks, the metropolitan area networks or MANs, wide area networks or WANs. And while we develop the network, these networks may be configured in there could be a combination of LAN and WAN, LAN, MAN and WAN, and so on. There could be number of iterations based on the requirement and the type of the organization and the type of use we want. For example, we hear the terminology a campus WAN or a campus LAN or a campus network. Let's say at Allama Iqbal Open University, when we call a campus network, it may involve a LANs, number of LANs. It may involve a MAN. Let's say Allama Iqbal Open University has number of campuses in the city, one in the one corner of the city, other on the other corner of the city, maybe connected with the central location of the university. We can call this a metropolitan area network. And when we connect our Allama Iqbal Open University's, let's say, main computing center with other cities, we can call that wide area network. And the number of iterations based on the type of network evolved, we can call it a campus network, or we can call another term which is very commonly used in the computing circles is the enterprise WAN or enterprise networks. Again, similarly, enterprise networks could involve LANs, MANs, and WANs as well. Local area network or the LAN is basically designed to cover small geographical areas. It may be in the shape of bus, ring, or a star network. It provides high data rates, and the speeds of from 10 megabit per second to 100 megabit per second are achievable. Broadcast is faster and cheap, and error rate is low in the LANs. Normally, it is these networks are privately owned, and the local area networks normally do not use the common carrier facilities or the facilities from the telcos. And IEEE 802 committee has developed the LAN standards, which are basically followed by all the manufacturers for the computing machinery to communicate effectively with each other. In this diagram, we see a typical LAN. It's not a very complex LAN. We see here the microcomputer attached with the network, printer, mini. Then on another network, we have the file system, mini and micro, and we see a gateway here. Whenever there is a protocol change in a network from machine A to machine, from the network A to network B, there is a gateway. Let's say this is a TCP/IP LAN and this is an SNA LAN. Whenever there is a protocol change, a gateway provides us the facility to so that the information generated in this network is understood by in the other side of the network. Similarly, in the LANs, we use number of servers, since there are large number of users on the LANs, and occasionally we require dedicated machines or dedicated servers to provide certain facilities so that the required level of service is available to our users. For example, we have the print server for print sharing, we have disk sharing, file and database services, and application services. We can have LAN servers to provide these services, dedicated, or one server may be able to provide more than one service to the users. Next type of the network we discussed is the MAN or metropolitan area network. Normally the 50 miles diameter, if we have a network which spans over the 50 miles or 50 kilometers diameter, we term that as MAN. And they can be a large LANs and may cover the entire city, typically 50 kilometer diameter, using different media including the cable TV facilities. And generally the metropolitan area networks are under the control of one authority, and users shared transmission medium, and data rates on the metropolitan area networks are from the 50 megabit per second to higher. There are a number of MAN standards which are followed in order to develop the metropolitan area networks, and these standards are the FDDI standard, for example, Fiber Distributed Data Interface standard. It is a popular MAN standard, operates at 100 megabit per second over 100 kilometers, and this standard is primarily aimed at the data communication users. The other MAN standard is DQDB, that is Distributed Queuing Dual Bus Standard, which has been adopted by IEEE 802-6 committee as a MAN standards, and it offers speeds up to 155 megabit per second data rates. The SMDS, that is switching megabit data service standard, which is being developed by the telephone companies as a MAN and WAN offering, and data rates from T1 to T3. T1 is 1.54 megabit per second to T3 is 45 megabit per second. And these standards are commonly used in the development and deployment of MAN. Now we come to the another type of the network, that is wide area networks. When we want to connect and communicate amongst the geographically distributed stations, let's say one computing facility is in Islamabad, another computing facility is in Lahore, yet another is in Karachi, another in Sialkot, and so on, and we want to connect them, we connect them with a wide area network, and we use the common carrier facilities. That is, we use facilities from the telecommunication carriers or telcos to connect these sites. And there are a number of options available from the communication carriers in order to connect these sites. And some of these are, as I mentioned, the wide area networks links geographically separated sites, maybe in different cities and even in different countries, and it provides point-to-point connection over a long-haul facilities from the telecommunication companies. And the facilities and the type of connections available from the telcos are the dial-up networks, which uses the voice grid lines. Then the leased line networks uses T1 or T3 facilities of the telecom operator, packet switching systems or X25 standard, or integrated services digital network facilities available from the telco. In this diagram, we'll just briefly discuss how a WAN or how the communication links between the WANs function. In this diagram, we see, let's say, the H stands for host. We have a host here. It may be in different city, another host in yet another city, another host in a different city or in the same city, and so here. And this is our communication subsystem. We see here the communication subsystem. And the communication subsystem here, and in this we see communication processor. Basically, from site A to go to any other site, we have to go to the communication processor, and this is primarily the cloud of the telco cloud. From our site, wherever the organization is, let's say this is Allama Iqbal Open University central site, this is Lahore, Karachi, Islamabad, Quetta, and so on. If we want to go from our Islamabad site to, let's say, Lahore, we have to go through the telecom network. This is our communication processor at our site, and there needs to be a network between our site here and, let's say, this is the telco's gateway located here. We have to have a network from our site to the telco site. Communication processor here travels over the telco network, communication processor at different site, and then again our host at a different location, let's say in Lahore. This is how the communication processors in a WAN are located and how they function. Dear students, we have discussed local area networks, metropolitan area networks, wide area networks, and they may be in the same geographical locale, scattered in a city, scattered in different city, or even scattered internationally. And obviously, the computing machines on that network or the communication machines on that network are not from the same vendor. They are from different vendors. Now, in order for these machines to communicate with each other seamlessly, we need a standard so that the information sent by one site or one machine to another should be understood and transferred seamlessly. The International Standards Organization's Open System Interconnection Model, reference model, as it's known, ISO, OSI, a reference model, provide us the guidelines and the standards for the equipment and the machinery from competing vendors to communicate seamlessly. Now we'll discuss the OSI reference model in some more details. OSI reference model, as we see in this diagram, provides us a layered architecture. It starts from the physical layer, layer 1, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Let's say we have computer A here, and in that computer we have these 7-layer OSI reference model. And we have another computer B. Again, in that computer we have the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. In all these, in order to, and we see here that this is our real system environment. This whole diagram is our real system environment. And these 7-layered architecture, as we call it, is the OSI environment. The 7 layers in our computer A and 7 layers in our computer B here. Then the 4 layers in this 7-layer model is our network environment. We see here physical, data link, network, and transport. This is basically our network environment, and this is physically the data network. We'll discuss all these 7 layers in a little details, that what are the functions of the physical layer and what are some of the examples of that these 7 layers. For example, in the physical layer, the function of the physical layer is to handle the mechanical and electrical details of the physical transmission of the bit streams originating from the station A or computer A and going to computer B. And the examples of that are RS-232 interface, RS-449 interface, X21 ISDN, or fiber distributed data interface, or the other interface. The physical interfaces which are connected to machine A and to machine B and join the networks, that is the physical layer. And the next is the data link layer. The function of the data link layer is it handles the frames or fixed length parts of the packets, including any error detection and recovery that occurred in the physical layer. That is the function of data link layer. The examples of data link layer are HDLC, IEEE 802.3, standard CSMA CD networks, we'll discuss briefly, IEEE 802.4 token bus networks, IEEE 802.5 token ring networks, IEEE 802.6 MAN standards, fiber distributed data interface, and integrated services digital network frames. These are the examples of data link layer. The next layer in the OSI reference model is the network layer, and the function of the network layer is that it provides connection and routes packet in the communication network, including handling the address of outgoing packets, decoding the addresses of incoming packets, and maintaining the routing information for proper response to changing the load levels. The examples of network layer are X25 and X75, or another example is ISDN interfaces I450 and I451. The next layer in OSI reference model is the transport layer, and the function of the transport layer is that it is responsible for low-level network access and for message transfer between clients, including partitioning the message into packets, maintaining packet order, controlling flow, and generating physical addresses for the data transfer. The examples of the transport layer are X214, transport service definition, and X224, transport service definition, which is equivalent to ISO 8072 and ISO 8073 standards. The next layer in the OSI reference model is the session layer, and session layer implements the sessions or process to process communication between the two machines. And the examples of the session layer are X215 session service and protocol definition, X225 session service and protocol definition, and which are also accepted as ISO 8326 and ISO 8327 standards. The next layer in the OSI reference model is the presentation layer, and presentation layer provides the management of entry, exchange, display, and control of data, interface transformation, and that is, it resolves the difference in the format among various sites in the network, including character conversions and half duplex, full duplex conversion. The examples of presentation layers are ISO 8822 connection oriented presentation, or ASN 1 abstract syntax notation 1 standard provides us the information on the presentation layer. Dear students, the seventh layer in OSI reference model is the application layer, and the application layer is the closest to the users. Rather, that is where the user comes in contact with this whole model, that is the application layer. And the function of the application layer is that it is user level formats, procedures, programs, operators, and devices are handled at the application layer level. And the number of examples in the application layer are, for example, virtual terminal, FTAM X400 email, then CMISE, which is Common Management Information Service Element, EDI, that is Electronic Data Interchange, ODA, Office Document Architecture, is another example of application layer. X409, the message handling system, and X500, the directory service. Dear students, this completes our discussion on the functions and examples of 7-layered OSI reference model. We'll be discussing in our distributed computing lectures and our client server lectures, we'll be discussing and repeating these 7-layered architecture OSI reference model again and again in various degrees. For now, it completes our discussion, and before we move to our next session, we would like to look at the format of a message and format of a packet in the inter machine or inter-site communication or communication in the network. We see here in this diagram, this is ISO network message. The format of the message is that we have a data link layer header, we have a network layer header, we have a transport layer header, a session layer header, a presentation layer header, an application layer, and actually the message and data link layer trailer. As we mentioned earlier, that in order for the machines to communicate, the machine A and machine B, they communicate under the 7-layer OSI reference model. And as we see in this diagram, the network message, the format of the network message involves all these layers in order for an effective communication between the two stations. Dear students, before we close our today's program, we'll discuss briefly an Ethernet packet and TCP/IP protocol layer. In this diagram, we see an Ethernet packet. We have a start of the packet, 7 bytes, start of the frame delimiter, 1 byte, destination address 2 or 6 bytes, source address, length of data section. Then we have the section for data, which can be up to 1500 bytes, then pad and frame checksum for error detection. This is the format of an Ethernet packet. Dear students, TCP/IP, the transmission control protocol, internet protocol, is universally used protocol and understood between various machines, various systems in order to have an effective communication. Let's look at the TCP/IP and how TCP/IP fits in our 7-layered architecture. In this diagram, we see we have a LAN or WAN. We start with the physical layer, data link layer, and network layer from layer 1 to 3. We have IEEE 802, X25 standards, Internet Protocol standard. And at layer 4, which is the transportation layer, we have the TCP, transmission control protocol, or we have UDP, which is user datagram protocol. And then from layer 5 to 7, we have a number of protocols, HTTP, which is hypertext transfer protocol, FTP, that is file transfer protocol, telnet or remote terminal protocol, simple mail transfer protocol, SMTP, domain name service protocol, and SNMP, which is simple network management protocol. This is how the TCP/IP protocol layers are can be compared with the 7-layered OSI reference model, which is universally used for the communication between the networks. This wraps up our today's program, and in summary, today we covered the local area networks, the metropolitan area networks, and wide area networks. And then we discussed in detail the OSI reference model and its 7 layers. These are physical layer, data link layer, network layer, transportation layer, session layer, presentation, and application layer. This concludes our today's discussion on the types of network and OSI reference model. Until next time, Allah Hafiz.